Our next topic is Bohr's atomic model. Bohr's model of hydrogen atom. Actually, his experiment is any closed container having it is filled with the hydrogen gas. So hydrogen is a gas, right? It is filled with hydrogen, and electricity is passed through these terminals, right? Positive terminal to negative terminal, right? Whenever the high electricity is passed through this gas, right, these two are not connected, only gas is helping to transfer the electricity, right? So it goes like this, right? Next, so it releases a spectra when one light which is coming from this container or tube, so it is passed through the prism, right? So this prism splits the whatever energy coming from this uh, vessel, so it is splitted into four colors. These colors are violet, blue, blue-green, red. This is the basic model of Bohr's model of hydrogen atom. Okay, right. From this he gave that uh, electrons in an atom occupy stationary orbits. Suppose if nucleus is there, right? If nucleus contains protons and neutrons together, right? So around the nucleus, electrons revolves in particular orbits, right? So like this, electrons revolve particular orbits. So he took model of solar system. Around the sun, planets revolve, right? Same model he explained here. Around the nucleus, electrons revolve in particular orbits, right? Suppose when any energy comes from outside to the this is gained by, this energy is gained by any electron of that atom, it jumps to the next orbital, right? So whenever it is getting energy and that energy is received by that electron, now it is called excited state. So before it is ground state. Normal position of electron in an atom is called ground state. Okay, so from ground state it is jumping to the higher orbital. So these are the lower orbitals, it is jumping to the higher orbital. Okay, right. So but it will not stay in that orbital. Again it comes to its original position by releasing the whatever energy it got in the form of heat or light. Suppose any chemical reaction is appearing in the underground by suppose. So there it releases heat energy, right? Maybe it is releasing that energy only. So this electron is jumping to the outermost orbital or next higher level, right? So this state is called excited state. It is coming from its ground level. Excited state to ground state. Okay, so it will not stay in that orbital continuously. Again it comes back to its ground state by releasing its energy in the form of heat energy or light energy. Okay, the energies of an electron, so whatever electrons are there, they are having some energies. They are indicated by E1, E2, E3, like this. Each electron will possess some energy levels. These are indicated by E1, E2, E3. The energy, and in this way the energy is quantized. The state of corresponding to these energies are called stationary states, and the possible values of energy are called energy levels. So these are the 3 point statements given by the Niels Bohr. That is, electrons occupy or stationary orbits in an atom around the nucleus. They rotate around the nucleus in their stationary orbits, but it is not correct. uh, okay, next, any if it is getting externally heat energy or light energy, that then it goes to the excited state from ground state, okay, to the higher orbital, right? But this electron will not stay in the higher orbital. Again it comes to its ground state by releasing this heat energy as heat energy or light energy. Next, energies of an electron in an atom can have a certain values like E1, E2, E3. Energies in this way, energies are quantized. The states corresponding to these energies are called stationary states. Next, and possible values are given like this. Next, lowest state of any electron is called ground state. Original state or lowest state of electron is called ground state. These electrons will not jump into the lower orbitals, but they can jump to the higher orbital whenever they get energy. Electron moves to higher energy level to the excited state by gaining energy. Okay. Next, but whenever it is going to the other outermost orbital, it will not stay there. So it loses its energy and comes back to its ground state. Next topic is quantum numbers. Before starting this, right, according to Bohr's atomic model, what he is saying, electrons revolve around the nucleus in particular orbits, right? So if they are revolving around the nucleus in particular orbits, we can find the electrons or velocity of electrons easily. But this is not happening originally. So if the electrons revolve around the nucleus, we define the path of orbits or orbits. The exact position of the electron at various times will be known. But we are not able to find where exactly we are able to find the electron. And if we know the path if they are revolving in particular orbits, so we can find at what time it will come to this position, right? After how much time it will come to its position. So we can find, in this way we can find velocity also. But it is not possible because these electrons are not visible to human naked eye, right? So to find out, so what you will do generally in a dark room to find any article, we use torchlight, right? To find these smallest particles, so we need a shorter wavelength. Shorter wavelength means like this, if any wavelength which is having highest frequency, right? So if you are giving this much of shortest frequency to any electron, it jumps from ground state to excited state. So will you say this is the ground state of electron? No. So this is not possible. In this way we cannot find the exact state of or where we find an electron in an orbit. Okay. Next, to understand the so generally we cannot find exact position of electron around the nucleus. To understand this properties of electrons in an atom, quantum mechanical model was developed by Erwin Schrödinger. According to this model, instead of orbits of Bohr's model, the electrons thought to exist in a particular region of space around the nucleus, right? So not these, from this what the scientist is telling, they do not follow the particular orbits, but they revolve around the particular region. Means if you take this as nucleus, these electrons, they do not follow orbits, but suppose if you are taking electrons in this region, they are revolving, they revolve in all the directions like this around the nucleus. They do not follow circular path, but they within the region they revolve in this like this. Okay. So to explain this, we need quantum numbers. What are quantum numbers? So quantum numbers are the set of numbers used to describe the position and energies of the electron okay, in an atom. So these numbers help us to find the position and their energy levels of atom, and how they are revolving around the nucleus, in which region they are revolving, what is the size of the atom, right? All this can be we can find easily using these quantum numbers, right? Also, these number indicate probability of, these quantum numbers also give information, probability of finding electron in the space around the nucleus. Okay, the set of numbers used to describe the position and energy of the electron in an atom also gives, these quantum numbers give probability of finding electron in the space around the nucleus. They are not using the orbit, so space around the nucleus where we can find the electron easily. That region only they are taking here, right? So here we have 4 quantum numbers, right? 4 quantum numbers. First one is principal quantum number. We will directly go to the principal quantum number. Okay, so it is indicated by n, right? Principal quantum number is related to the size and energy of the orbital. Size and energy of the main shell. Okay, suppose nucleus, around the nucleus, around the region, this region means we have to take 360 degrees, right? So probability of finding electron within this region is more, means, so this is the size of the atom, means electron is revolving in this region, not going crossing this range. Okay, not crossing this region, right? Principal quantum numbers provide size and energy of the main shell, right? N has values, it is indicated with n, and values are assigned as 1, 2, 3, 4, like this, right? As n increases, shells become, suppose if n value is 2, second orbital is like this, third orbital means 1, 2, 3. We can write this principal quantum number also like this. If I take shell value K, L, M, okay, like this. If n value increases, size of the atom also increases, right? Next, these are also represented by K, L, M, N. Main shells also represented by K, L, M, N. N values are assigned as 1, 2, 3, 4. Next, angular momentum. Angular momentum quantum number. Okay, angular momentum quantum number. So it is represented by L. L formula is given as n minus 1. So what n indicates? It indicates principal quantum numbers. Okay, L values taken as 0, 1, 2, 3. Right? So here angular momentum which indicates the suborbitals. It gives the information related to the shape of the particular subshell. Shape of subshell. Right. Subshell. So where these subshells are located? Space around the nucleus. Space around the nucleus. Right. So here, what are subshells? Whatever we are discussing, electrons are revolving within the region, right? But they follow particular shapes whenever revolving around the nucleus. Suppose if L value is 0, means first principal quantum number, right? If n equals to 1, and L value will be 0, 1 minus 1, 0. right? This shape is given by sphere or S. S shape means electrons within the region revolve in the shape of sphere shape, like this one. It may revolve any, but it takes only sphere shape within the region. It will not cross that region. Okay. If L value equals to 1, electrons revolve around the nucleus in dumbbell shape. Dumbbell. Right? Dumbbell. Next, L, if it is 1. If it is 1. Dumbbell shape. So, dumbbell shape means shape will be like this. Okay. Here we have not only exact like this. If it is in the x-axis, one orbit dumbbell shape will be in the y-axis. Then we have one more shape, double dumbbell. Z, dumbbell shape Z. So in this 3 axis dumbbell shape we'll find generally. Okay. So the electron may revolve in the dumbbell shape on x-axis, y-axis or z-axis. Right. Next, if L value is 1, if L value is 1, dumbbell shape. L value is 2, when it will be 2? If it is 1 means N equals to 2 here. N equals to 1 means main shell name is K, here L. If principal quantum number 3, L value become N minus 1, right? So you will get L equals to 2. If L value is 2, the shape of the suborbital is double dumbbell. Like this. One time it rotates in x-axis. Okay, we are having 5 types of double dumbbell shapes. Okay, next. So we are having 5 types of double dumbbell shapes. 5 we have. I'm not drawing all. X, Y, X, Y, Z, X. Like this we'll have one more. Like this. So these are the 5 double dumbbell shapes. 5 double dumbbell. Okay. Next, from this what we can say is, if you see, observe, if L equals to, if L value is, we will write a box like this. Principal quantum number I am taking 1, 2, 3, 4. Right? Shape of, we can represent it as K, L, M, N. This is N. Right? L values 0, 1, 2, 3. Right? Next, the name of the subshell. Name of subshell. So it is S, P, D, F. S, sphere shape, means electrons revolve around the nucleus in the shape of sphere. Right? P means electrons revolve in the shape of dumbbell around the nucleus. Okay, within the specified region. Next, D, double dumbbell. F means 4 folds. 4 folds. Okay. Next, magnetic quantum number. Third quantum number is magnetic quantum number. So it is represented by ml. Okay. Formula is given as 2L plus 1. Right? Magnetic quantum number. What it says actually. Magnetic quantum number indicates the orbitals in a subshell. Indicates the number of subshells and describes the orientation. Also, it describes the orientation of an electron electron's orbital within the specified within a subshell. Right. Now up to now we discussed principal quantum number. What it indicates? Principal quantum number indicates electrons revolve around the nucleus within the specified region, right? Angular momentum quantum number says that number of subshells, right? Shape of the subshell. It tells us shape of the subshell. What? Angular momentum. But here how the shapes are given. S, P, D, F. Next, magnetic quantum number says orientation of an electron. Orientation of an subshell. How the electrons orbital within the subshell and their orientation. Means how the specifies the orbital's angular momentum. What orientation means? Specifies the orbital's angular momentum. So how much angle they are making, how they are revolving, like that. Angular momentum along the given axis. Right. So ml values are taken by formula 2l plus 1, right? If L equals to 0, what is ml value? 1. Only 1, right? Means here it gives the information about we can say directly, indirectly, assigning values to the degenerated orbitals or subshells. Degenerated. What is degenerated means? Suppose s orbital, we have only one shape. So L value is n equals to 1, L equals to 0, and values for this orbital is 0 only. ML value will be 0 only. If S, then next P, we will take P. N equals to 2, right? Next, L value will be 1. And the shape of the subshell is 1. Values for these orbitals, we can give it as 0, minus 1, plus 1, like this. How many orbitals we have in this piece? Dumbbell shape only we are using word, but in this dumbbell shape we are having 3 dumbbell shapes, x-axis, y-axis, z-axis. So ml values can be given as minus 1, plus 1, like this. We are assigning values to these degenerated orbitals. Next, double dumbbell, L value will be 2. Okay, n will be, you can leave this, n will be 3. N is 3, L equals to 2. Then values. How many dumbbell shapes we have? We have 5 dumbbell shapes. Right? Means we have to assign 5 values. One of the value should be 0. So middle value should be 0. And the value starts from minus 2, minus 1, plus 1, plus 2. Like this. Next we will have F. N is 4. L value is 3. Means minus 3, minus 2, minus 1, 0. Plus 1, plus 2, plus 3. Like 7 orbitals are there in 4 folds. F means 4-fold orbital subshell, right? So that subshell degenerated orbital ML values are given as minus 3 to plus 3. So from this we can say L values lies always from plus L to minus L, including 0. Plus L to minus L. If L is 0, only one value you will get. If it is 1, minus plus 1, 0, minus 1. If it is 2, plus 2, plus 1, 0, minus 1, minus 2. Like that. Clear? Next, we have spin quantum number. Spin quantum number. Right. Suppose, up to now what we discussed, electrons revolve around the region, around the space of nucleus. Particular, it restricted to that region only. It will not cross the region. So most probably we will find in this region only that electron. Right? Suppose these here whatever electrons are there, so they revolve around the nucleus in different shapes. Okay. Next, these are called main shells. K, L or 1, 2, 3 values are given, and it is in, we can use this word principal quantum number. Next, what angular momentum quantum number is telling? Shape of the subshell. So it is telling about shape. So in which shape some are revolving around the nucleus in sphere shape only. Right? So within the, some are revolving in dumbbell shape like this. Okay, some are in double dumbbell shape. Next, and the third, magnetic quantum number giving the orientation of the orbitals. How much angle it is making and values for the orbitals. Okay, if I taking as base this one, so angle between these two we have to take. Suppose if I draw these at a time, I'll get like this, I'll get like this. So middle one if I take, suppose if I am taking this as axis, so minus 1 we can take 0 plus 1 like this. So that is magnetic values. Next, spin quantum number. Each subshell assigned with only 2 electrons. 2 electrons. But if I take these values for this 2 electrons, if I write 3 principal quantum numbers, main shell will be 1. For both the electrons it will be 1 only. Suppose if these 2 electrons are revolving around the nucleus within the specified region like this, only these 2 electrons revolving in first main shell, right? Principal quantum number will be 1 for both the electrons. But next, angular momentum, right? L value is given as 0, 0. Both will have 0 only. So shape of the orbital is S. Subshell orbital is sphere only. Both will have same. And magnetic quantum number means orientation of the orbital. So values assigned as 0 for sphere, already what we discussed. Means our basic what principal quantum numbers, whatever we studied in starting of the lesson, this topic, what quantum numbers are giving? Quantum numbers are providing the information where we find them and their sizes and energies. So here, but no 2 electrons to have the these 3 means no 2 electrons should have same quantum number. But here whatever we are getting values all are same. Only one thing changes is spin of the electron. Right? I think everyone know what is spin. Suppose if I take this orbital, every suborbital will have only 2 electrons. Right? 2 means suppose s orbital will have only one orbital, one subshell. It is with subshell on sphere shape and it is having 2 electrons only. Now I'll explain here. You take this picture. It is nucleus. Around the nucleus, first orbital, main shell started, right? K equals to 1, first orbital. So how many electrons can occupy maximum here? 2 only, right? What is the shape of the subshell here? How they are revolving around the nucleus means sphere shape only. These 2 electrons will rotate in the shape of sphere shape only. But all the quantum numbers are same, but the difference should be there. that comes with one electron, it is rotating in clockwise direction, other electron will rotate in anti-clockwise direction. So suppose if you are having suppose if you think here no electron is there, but it is going to occupied by some electron. So how it will be occupied? With opposite spin. If it is having clockwise, this will be occupied by opposite spin, anti-clockwise, right? Suppose second orbital started, if you take carbon, nitrogen, there we will have second orbital also, k value is 2, kl, this is L. Second orbital, L value 2. Next, how the electrons are revolving. First two electrons, suppose if I take oxygen, how many electrons are there in oxygen? 8. Means first two electrons revolve in first main shell, sphere, and next 6 are electrons are in the second main shell. 6 are there, but these 6 are occupied by other means these 6 orbital electrons revolve in dumbbell shape. First two will revolve in sphere, then second are remaining 6 are in dumbbell shape. Means dumbbell we have again 3 shapes, x-axis, y-axis and z-axis. 2 electrons will be in x-axis dumbbell shape, means here y-axis, remaining 2 will come into z-axis. Right. 2, 4, not this one, we'll leave this one. Right. First 8 electrons, first 2 come into first orbital, next 2 electrons revolve in sphere shape and 4 electrons revolve in dumbbell shape. So dumbbell shape, only 2 orbitals, suborbitals will be occupied with 4 electrons like this. Right. Next, how the and the spin only differences here. One will be in clockwise direction, second is in anti-clockwise direction. And values are ranging from minus L to minus L, 0 to plus L. Clear? Next,